Good afternoon, everyone. I'm loading a video here for those of you that still haven't retaken your complex number test, and so I thought I'd give you one more chance to study, and if you can't ask questions, at least you can see some things solved. So go ahead and read this page. We're moving on, and remember to fast forward to the problems you need help with, and when you need to see something again, stop and rewind, watch it again, okay? Here we go. Alright, so the first question we're looking at here, these are the radicals, the imaginaries that you have to simplify. So if you're still struggling with this, take a look at this this video page here. So first thing you have to remember when we're doing radicals is you always have to take the I out first. So first we're going to take that I out and we're going to rework it. So we have the square root of 84. We're going to get that I out of there. Now we need to look to see if there's a real perfect square in 84. So I'm going to go ahead and use the factor tree to see if I can find that. I'm going to cut 84 in half. That's 2 times 42. I'm going to cut 42 in half. That's 2 times 21. 21 I'm going to bring down to 3 and 7. All of these are done. I can't factor those numbers down any further. So I'm going to finalize my answer here by go ahead and writing all of my numbers, my factors, my prime factors. And then I'm going to find my pairs. There's a pair that's a perfect square. It's 4. And the square root of 4 is 2. I'm going to multiply these two back together and drop my I in there. Remember sometimes, folks, that on different textbooks and different texts, sometimes the I will be in this position, but remember that this is the most proper way to write that. Moving on to number 2. Now the difference between number 2 and number 1 is that you have an opposite symbol out here which says the opposite of or negative, whatever it is. So again, the I comes out. Everything else is going to stay exactly the way it is and continue to work it down. So we're going to break up that 12 into, we'll do 4 times 3 and 2 times 2. Those cannot be broken down any further, so we're going to finalize. The negative comes down, or the opposite. Square root of 2 times 3, I. Again, this is 4. The square root of 4, that's a pair, is 2. So we're going to take that 2 out, leaving the 3 in, and there's your answer. Negative 2 square root of 3, I. Now these ones are a little bit different because I'm asking you to add these together. Well, you can't add them together the way they are because they're different types of numbers. So what you have to do first is you have to write them in their simplest form like these other two answers that we have here. So same process, you're just going to do both of them and see if they're like. So here's how we work it. We're going to take the I out and take the I out. So we have the square root of 24I plus the square root of 96I. And we have to continue working these out separately, and then we're going to add them together. So 24 is going to break down to 2 times 12, 2 times 6, and 2 times 3. I'm going to go ahead and finalize all of those. So we have the square root of 2 times 2 times 2 times 3, and then we have that I that we took out. We had a pair of 2's, so that 2's coming out. The 2 times 3 is going to go back together to be a 6, and we have the I. And there's nothing else to do with that one. We're going to do the same thing with the 96. Cutting that in half, that's 2 times 48. That 48 is going to break in half into 2 times 24, and then the 24 we just broke down was 2 and 12, 2 and 6, 2 and 3. I'm going to go ahead and make that a little bit smaller if I can. Maybe not. I'll have to scoot this stuff down to make it work. So I'll bring this down here a little bit. Plus. And we're going to do this one. So this one worked out to be 1, 2, 3, 4, 5 2's. So 2 times 2 times 2 times 2 times 3. So hang on a second, let me check my math. 2 times 48. I'm going to pause for a moment. Okay, so I see what I did. I just have a 1, 2, 3, 4, 5 2's. So let me fix that up. So I would have had 5 2's in there. So 1, 2, 3, 4, 5 2's and the 3 and the I. Sorry about the mess, but you know how I do. There's a 2 that's coming out. There's a 2 that's coming out. And then you have the 2 times 3 left that are not a pair. They're going back in. And so we get this. 2 times 2 is 4, square root of 6i. Now that we have those done, folks, we can add these numbers. They have the same ending. So what you're going to add is those running coefficients there of 2 plus 4. So you get 6 the square root of 6i. Okay? Never add the numbers underneath the square roots. We can multiply things like that, but we can't add them. Okay, so carefully to break them down, and if they have matching square roots and matching variables or imaginaries, then you can add the numbers that you took out of the originals. Okay, next one here we have a multiplication problem. It's the same process as before. So what you're going to do, take out your i's. So you have the square root of 6i times the square root of 15i. And we are going to break these down and rewrite them. So we're going to do breaking both of them down, and we're going to put them all together. 2 times 3 and 3 times 5 is 15. So we're going to rearrange this so we have 2 times 3 times 3 times 5, all of them, because we are multiplying them all together. And also we have this double I, which is I times I, which is I squared. Now in here we have a pair of 3's, which 3 times 3 is 9. The square root of 9 is 3, so the 3's coming out. The 2 times 5 is staying in. And then we have the I squared. Remembering that I squared will change the sign of anything, we're going to take that I squared, cancel it out, make this a negative answer, and so your final answer, 3 the square root of 10. Okay? Here's this next one. Be very careful to pay attention to the fact that this is not a distribution or FOIL problem. So it's an addition problem. So all you've got to understand is this is a complex number plus another complex number. So distributing the one that's in front, you get 7 minus 3i plus 4 plus 9i. And then you're going to regroup your like numbers, putting your real numbers first and your imaginary numbers second. So 7 plus 4 minus 3i plus 9i. And then combining your like terms, you get 11. Then you're going to combine the front numbers. Negative 3 plus 9 is positive 6i. And you're finished. You're just adding the like. So 7 plus 4, 11. Negative 3 plus 9, 6i. And there you have that one. Same process over here, except that this time you're subtracting. So you're doing 5 minus 4, and then you're doing negative 2i minus negative I. So what makes this easier is to just go ahead and distribute this 1 and this negative 1. So you get 5 minus 2i, and then negative 1 times 4 is negative 4. Negative 1 times negative I is positive 1i. Same process as the other, this number 5. You're just regrouping, so putting the real numbers first and then the imaginary numbers second. 5 minus 4 is 1. And then here you have a negative 2 plus this imaginary 1 right here. Negative 2 plus 1 is negative 1. So minus 1i, so negative I. And there you have that answer. Okay, that's subtraction and addition. So please remember to be careful about the signs that are between the complex numbers. Next we have multiplication. Now you are going to use your distribution or FOIL. So for this one you're going to be multiplying and multiplying and coming back and multiplying And there we go. So first we're going to do 8 times 9 is positive 72. 8 times negative 5 is negative 40. I, because we've got the I here coming back, positive 2i times 9 is positive 18i. And then positive 2i times negative 5i is negative 10i squared. Alright? Now we have to combine like terms with the real numbers in the front and the i's and the imaginaries in the back. So first we're going to do the I squared makes this a positive 10, and we're going to regroup. So we're going to do 72 positive 10 because it's a plus 10 minus 40i plus 18i. Move just like now it's addition or subtraction. 72 plus 10 is 82, and negative 40 plus 18 is negative 22i. A plus bi, real plus imaginary. There you have that one. Now this one, remember, don't make this mistake. We are not going to square a 4 and square an 8. We are squaring this complex number. So it's 4 minus 8i times 4 minus 8i. And then same exact process as this here. You're going to multiply over the top, multiply over under the bottom. So you have 16 minus 32i. Again, minus 32i, those should be the same. And then negative 8 times negative 8 is positive 64. I times I squared. I squared makes a positive 64, a negative 64. Then we rearrange 16 and minus 64, minus 32i, minus 32i. Combining like terms, you get 16 minus 64. So that's going to be a negative 48, and then negative 32, and negative 32 is a negative 64. You've got a calculator, just double check your math. I'm going to double check my math really quick. 6, 5, 14, that's 8. Yes, negative 48. Okay, and so there's your answer. Alright, moving on to what do we do when we have to, what we're doing here is we're rationalizing the denominator. Now remember that denominators are pretty irrational. They don't like to have any weird things in their place. So when you're rationalizing your denominator, remember that the 9 is okay. This denominator likes a 9. It does not like the I. How do we get rid of the I? We got to multiply it times I. Because I times I is I squared, and I squared equals negative 1. But we got to multiply top and bottom. So we're moving that I to the top. So we get 8 times I is 8i, and on the bottom we get 9 times I is 9i squared. And then we need to simplify. I squared makes us a negative 9. And then we have to write it correctly. So we think positive divided by negative is negative 8/9. And remember that the I likes to be by itself, so it's just going to drop right out of the numerator. Then you need to make sure that you can't reduce 8/9 or divide 8/9, and you can't, and so that one's done. This one here has another unhappy denominator. The 3 is okay and the 6 is okay, but how do we turn this into just a number? We can't just multiply it times I like we did over here, because if we multiply this times I, you're going to end up with 3i plus 6i squared, and you still have the situation of i's. So remember that when you do the complex numbers in your denominator, you have to multiply by the complex conjugate. So you're going to have the problem 4 minus 2i over 3 plus 6i. We got to make this denominator happy. We're going to multiply by the conjugate of 3 plus 6i, which is 3 minus 6i. Now remember, you got to multiply to the top and the bottom when you're changing a fraction. So on the top you're going to be foiling just like all of these last other problems. And then on the bottom we're going to multiply as well. But remember that when we multiply complex conjugates, when we're in our steps for FOIL, we get to cancel the O and the I, the outer multiplication and the inner multiplication. So we just have to multiply first and last. Alright, so let's work on the top here. We got to multiply 4 times 3 is 12. 4 times negative 6 is negative 18i. Negative 2 times 3 is negative 6. And then we have that I, and then negative 2 times negative 6 positive 12. I times I is I squared. Okay? And we'll rearrange this in a minute. Let's work on this bottom here. Again, we're multiplying conjugates, so we just have to do the top, the front, and the last. So 3 times 3 is 9. 6 times negative 6 is negative 36. I times I is I squared. Now what we're going to do, folks, is we're going to simplify and rewrite. So we're going to take this I squared and make that a negative 12. And we're going to rewrite this problem. So look what we're going to get. 12 minus 12. So we get 12 minus 12 minus 18I minus 6I all over. This I squared is going to make that a positive 36. 9 plus 36 is 45. And now what we have to do, folks, we have to finish this. So this is 0. We have our 0. And then negative 18 minus 6 is negative 24I. And so that's our simplified version of that. So we're going to get 0 minus 24I all over 45. But remember that your answer has to be in the form a plus bi. We always separate our real from our imaginary. So what we're going to do is we're going to put the 45 under each number separately. Minus 24 over 45i. We're running out of space here. Okay, so 0 minus 45 over 0 divided by 45 is 0. So we got the 0. And then 24 and 45 actually we can reduce because 3 goes into both of those. 3 goes into 24 8 times, and 3 goes into 45 15 times. And so our final answer for this one, 0 plus minus 18, 8/15ths I. Okay? Last page is the powers of I. Remember that there are only 4 powers of I. And once you get to I to the 5th, remember that it just starts over. I to the 5th is I to the 6th, negative 1, etc. So we divide by 4 to figure out where in the pattern is the 29. So all we do is we divide 4 into 29. 4 goes into 29 7 times. 7 times 4 is 28. Subtract, we get a remainder of 1. So that means that I to the 29th is going to be up here and I to the 1. So our answer to this, I to the remainder of 1, is I. So the answer to this one is I. Second one over here, we have the issue of it being a negative exponent. So first we have to make it a positive exponent by dropping the I to the denominator. But then we have to make our denominator happy because denominators don't like i's. It wants to kick it right back out of there. So first let's figure out what our remainder is. So again we're going to do 4 into 75. 4 goes into 7 once. Doing math in my head here. 1 times 4. 7 minus 4 is 3. And 4 goes into 35. Let's see, that's 8 times. And we get 32. And folks, we have a remainder of 3. So when we have a remainder of 3, that gives us I cubed. So we have 1 over I cubed. And I cubed equals negative I. So final, we have that. Oops, I better hurry. Last thing is, our denominator's still unhappy, so we've got to kick that I out. So just like before, we're going to rationalize this denominator. We're going to multiply it times I over I. 1 times I is I. Negative I times positive I is negative I squared. I squared makes that negative, a positive, and it's a positive 1. So I divided by 1 is I. And there you have your second answer. All right? And that is all. If you need to watch it again, go ahead, and I'll see you tomorrow. Make sure you get this taken care of soon. Have a good day.